Find the Laplace transform of sine squared t. So we're going to have to use our half-angle identity, where sine squared of t equals 1/2 parentheses 1 minus cosine of 2t, which essentially just equals 1/2 minus 1/2 cosine of 2t. Substituting that within the Laplace term, that becomes Laplace of 1/2 minus 1/2 cosine of 2t. Since these two terms are being added together, or rather subtracted, we can split them apart, and through linearity, you can bring out the coefficient out in the front. So this becomes 1/2 Laplace of 1 minus 1/2 Laplace of cosine of 2t. We know from our table, Laplace of 1 equals 1 over s, and Laplace of cosine of bt, where b's any constant, equals s over s squared plus b squared. In our case, we have Laplace of cosine of 2t, so we can let b equal 2. So it becomes s over s squared plus 4, or 2 squared. It doesn't really matter. With these terms, it can become 1/2. Our Laplace of 1 we said was 1 over s, minus 1/2 Laplace of cosine of 2t is s over s squared plus 4. And that equals our final answer of 1 over 2s minus s over 2 parentheses s squared plus 4. For more free solutions, please like and subscribe, and I'll see you in the next video.